So you just learnt about simple interest. Now what about compound interest? Now most savings accounts actually pay compound interest due to its higher amounts that will pay you in terms of interest. So compound interest is always better than simple interest, except in one particular case, which I'll address in a second. If we have a look at the graph of simple interest over time versus compound interest, the simple interest graph is a straight line as indicated here below. Okay, so that means that every single time you run by some number of years, okay, let's just say 1 year, it grows by this much. But if you look at the next year, it grows by this much, next year grows by this much. And you can see that the amount it grows by is always going to be the same. And that's because the interest depends on one solid principle at the very beginning. But the graph of compound interest over time is a curve, meaning it grows like this exponentially. So it's going to grow faster and faster and faster because your principal keeps growing, and so your interest keeps growing. The only time where the compound interest is lower than the simple interest is when it's between the beginning to the first year. But once you get past that first year, the compound interest rises much quicker. Now, let's take a look at an example to see what the difference is. A principal of $3,000 is invested at 6% per annum yearly. So this is using compound interest. Now find the amount of interest after 3 years and also find the amount of interest after n years. Now let's just not look at the thing where we have to calculate compound interest first. Let's do this using simple interest and see what happens after every single year, as I said before. Now, if we're looking at a duration of 3 years, okay, first, second, and third year, let's have a look at what happens in each year. We know that our principal is 3,000 and it's invested about 6%. So that means if we times by 0.06, we get $180. In the second year, this principal stays the same. It does not change. So if we get 3,000 times 0.06 again, we get $180. And if we do that again, we still get $180. So every single year, they are just increasing that original amount by $180. That's how much extra money you are getting. But when you have a look at compound interest, right? Okay, A1, which is the amount after the first year, is $3,000 plus 6% of 3,000, which is the same thing as 0.06 times 3,000. That is the same thing as 3,000 times 1.06, or the same thing as timesing or multiplying 106%. Okay, now that gives you 3,180. So after we do that, how much interest have I actually gained? Well, the interest here is basically 3,180 minus the principal of 3,000, which is going to be $180. Okay. Then if we have a look at A2, A2 would now use this number as our new principal, because that's what's in the bank account right now. And I'm going to skip this step because you're just going to be basically adding 6% of 3,180. But the quick way to doing this is to multiply by 1.06. This would add 6% of this value to itself. Now, when I multiply that on my calculator, I will get 3370.80. Okay, so I guess I don't need this and this. But what do we notice about our interest now? Our interest is going to be this amount, so 3370.80, but we have to subtract by the principal that we started off at the beginning of the second year. Okay, so 3,180. And what would you notice when you subtract these two numbers? Let's find out. We get an interest of $190.80. Now, if we continue into A3, we get A2's amount, which is now the amount sitting in the bank. We have to increase this by 6% because that's what the bank pays us. So it times by 1.06, and 3370.8 times 1.06. That gives us 3,573 and 4.8 cents. Okay, which I'll write that completely. Now, what's our interest now? That will be this amount that we just got. But we have to minus what the principal was at the beginning of the third year, which is this amount here. So if I then do that on the calculator, I will get $202.24.8. Okay, so what I want you to notice here is when you compare compound interest and simple interest, we saw that the simple interest was $180 every single time. But when you have a look at the interest paid on, if it's by compound interest, the first year earns $180, which is the same as this. But if you have a look at the second year, this is way more than this amount. Okay, it's $10.80 more than that. And then this is now much more than that. Okay, so we can see that as we look at the interests again and again and again, this is rising, okay, more and more and more, okay? Then this happens because our principal, which was 3,000 originally, is growing higher and higher and higher. And it's not growing by that same amount. It's growing by a percentage, okay? In fact, 6% more than previous ones, okay? So how do we now find out, for question B, the amount of the investment after n years? Well, if we have a look at these lines here, okay, what are we actually growing? We're actually growing this amount here by 6% every single time, okay? In fact, this line here is 3,000 times 1.06 times 1.06, because we took this amount from this amount, and this was 3,000 times 1.06. So this is the same thing as 1.06 squared. Okay, I'll write that different color. Okay, 3,000 times 1.06 squared. So what about this one then? This was taking this previous amount, which is this or this amount, and we'll multiply that by another 1.06. So this amount here is actually the same as 3,000 times 1.06 cubed. So if we have a look at the pattern, after the second year, it's times by 1.06 squared. So there's your power that matches this. And after the third year, the power is now 3. So what about if it's the nth year? Okay, so where n is some number that we don't know. Okay, it could be 5 years, 6 years, 7 years, whatever it is. This would now be 3,000 times 1.06, but now to the power of n. We can also write that as an being 3,000 brackets 1.06 to the power of n. Okay, as some textbooks might write that way.